here on this one with this, which is special right triangles. There are a couple triangles that you have to know without a calculator. Oftentimes they're used on SATs or ACTs. I know if you're in the AP Calculus next year, they're going to be in there. Your college professor would ask you to know these as well. They come from two different types of triangles. One is a triangle that has 45-degree angle, another 45-degree angle, and a 90-degree angle. So 45, 45, 90. And those are talking, and so this one is when we have a reference angle of 45 degrees. So if we have a reference angle of 45 degrees, here's what we got. Here's what that picture looks like. And actually, I'm going to draw this a little different. I'm going to draw it so it's in the first quadrant. This is the way you would see it. And with a 45-degree angle and another 45-degree angle and a 90-degree angle, these two sides are actually the same. Now, we could do the Pythagorean theorem, and I can show you how the Pythagorean theorem works. But if I make this hypotenuse 1, this side over here is the square root of 2 over 2. And this side right here is the square root of 2 over 2. Now, if you want to know why that is, you could do the Pythagorean theorem. You could just take a triangle, something like this, and make this 1, make this x, and this x, and you could solve x squared plus x squared is equal to 1 squared. So 2x squared is equal to 1. And then you could go through and continue to solve that. What you'll end up with is you'll end up with those values. Now that's an important piece. So if you think about like what this looks like, if we were to do the sine of 45 degrees, that would be the opposite. If this is our angle, this is the opposite side divided by the hypotenuse. And notice, look at the hypotenuse, it's 1. This is the adjacent side divided by the hypotenuse, which is 1. So the opposite divided by the adjacent is the square root of 2 over 2 divided by 1, which is just the square root of 2 over 2. The cosine of 45 degrees is also the adjacent over the hypotenuse. So both of those are the square root of 2 over 2. Now, they might be in a different place, so we might need to have them be negative. Notice that if you think about in terms of this is vertical, so that's the y value. Notice that this one is horizontal. That's the x value. And we'll talk about that in a second when we talk about how we might draw these. That might help you. Maybe you can just kind of keep that in the back of your mind for right now. We're going to talk about that in a second. So that's one of the special right triangles. The other special right triangle is one where you have a 30-degree angle, a 60-degree angle, and a 90-degree angle. And you're going to have this triangle either oriented like this, where the 60-degree angle is right here. This is 90, this would be 30. Again, if I make this 1, this is half of it, and this one is actually the square root of 3 over 2. And this is something you just have to memorize. If you were to write it down 10 times, you'd end up with the same. You'd have it memorized, I'm sure. So if this is 30 degrees, this is 90, and this is 60, this is now the 1/2 side. This is the hypotenuse is still 1, and this is the square root of 3 over 2. Now I drew them that way because we're going to be talking about 60-degree reference angles or 30-degree reference angles. Notice on a 60-degree reference angle, that the sine of 60 degrees is the square root of 3 over 2. The cosine of 60 degrees is 1/2. But notice what happens when you check out the complement to that. So the sine of 30 degrees is equal to 1/2, and the cosine of 30 degrees is equal to the square root of 3 over 2. So we have these different sides. So let me show you what type of problem you're going to have. You're going to have a problem that's something like this. And we're going to, so think of this circle as being a rotation of this green dot, okay? So it says, given the following circle, rotate the green dot to the appropriate angle and then find the exact value of the function. Notice if I rotate this around, and I'm going to get a different problem, so hold on. Let me go back here, dump those, and let me go to the problem now. So 300 degrees. So let me just draw this. Go 300. So you know that that's 90, 180, 270, and that's going to be around 300, 60 degrees short of 360, right? And if you think about where 300 is, if we have a circle and we draw, if we have these axes that go through it, this is 0, this is 180, and we go all the way back over here is 360, then 300 is going to be right down here. It's going to go all the way around to there, which makes our reference angle 60 degrees, right? Makes this angle 60 degrees. Now, if you drop this triangle down to there, notice what that makes. That makes a triangle that we have flipped around. But it looks really like the other triangles that we were just talking about. We were just talking about triangles look like this. It looks like this one on the left that's just flipped over. So let's talk about these sides. If you go back, we know that this side is 1. We know this side is 1/2. That's positive 1/2 because we're going in the positive direction here, and we're going in the negative direction here. This is the positive y, and this is the negative y. Remember what I talked about with positive y or with the y value? Notice that since this is going down, we know that it's the square root of 3 over 2, but because it's going down, we're going to make it negative. That means when we're doing the sine, when we're thinking about the sine of 300 degrees with that triangle, we would do the opposite side divided by the hypotenuse, or just negative square root of 3 over 2. And you should be able to pull square roots over here and get them. So you should be able to go negative square root 3 divided by 2. And that should give you the value that you're looking for right there. And it goes through the reference angle and shows you how to do it. Let me show you another problem. Let me do like this one, cosine of 135, and then I'll give you time to work on these. So the next one, cosine of 135. So let's think about the graph here. Actually, I'm going to make that a little bigger so I can draw on it appropriately. So I draw my circle there, and I think about 135. So this over here is 0 again, and it may be helpful for you to just draw this several times. So that we're looking for the cosine of 135. We know that this is 180, so we haven't quite got to 180 yet. So 135 is right in this quadrant. Now, if we wanted to know, well, what angle is this right here? That reference angle is equal to 180 minus 135, which is actually equal to 45. So if you drop this down, notice what you get here. You get that 45, 45, 90 triangle. Now, if you think about what we've done, this is 1. That's the hypotenuse. That's always going to be positive. It's always 1. It's a spoke of a wheel. Now, if you think about this side over here, this is a square root of 2 over 2. And this is the positive direction for y, where this would be the negative direction for y. And notice our y value is going in the positive direction. Our x value, this is the positive x values. This is the negative x values, because remember, these are x and these are y. And notice we're going back, so we're going to do negative on that. Negative square root of 2 over 2, because we're going back this way is a negative direction from our origin at 0. So if we wanted to know the cosine of 135 degrees, cosine of 135 degrees is the adjacent side, which is negative root 2 over 2, divided by 1. So the cosine of 135 degrees is equal to the adjacent divided by the hypotenuse. So if we were to put in negative, go over here and we did negative root 3 or 2 divided by 2, submit the answer, and what I put on there, I'm not sure why they counted that off, because I wrote the same thing they did. So I'm not sure why they counted that one off. Other than maybe they didn't like my negative on there. But hopefully, if something goes on, maybe they didn't like the way I typed that in. So I'm not sure what was wrong with the way I typed that in, but it is negative root 2 over 2. If you have trouble with that, let me know and I will help you. So let me know if you have any questions, and that should get you started.